Section of solids. Many a times it becomes important to showcase internal structure of a component along with its outer structure to maintain the context while drafting an engineering drawing. In that case, the component or object is cut by some imaginary plane in order to show the internal details. The action of cutting is called sectioning of a solid, and the imaginary plane of cutting is called section plane. Clear understanding of section of solid concept is very important for a designer as it helps to articulate the details of the internal structure of a component clearly and unambiguously to facilitate ease of manufacturing with greater precision and accuracy. The content of this topic will help you understand critical concepts related to the section of solids. In addition, you will also learn industry relevance of section of solids, importance of section of solids, types of section views. The content is supplemented with industry-specific examples to enhance your learning. In engineering industries, when the internal structure of an object is complicated, it is very difficult to visualize the object from its orthographic views since there will be several hidden lines. For example, in case of piston head, the internal details are shown by sectional views. While in case of a spoke, wheel sectional views are an important aspect of design and documentation, since it is used to improve clarity and reveal interior features of parts. In case of connecting rod, sectional drawings are multi-view technical drawings that contain special views of a part or parts that reveal interior features. Here are some key points with respect to section views. The imaginary plane is called a section plane or a cutting plane. The surface produced by cutting the object by the section plane is called as the section. It is shown by thin section lines uniformly spaced and inclined at 45 degrees. The projection of the section along with the remaining portion of the object is called a sectional view. A primary reason for creating a section view is the elimination of hidden lines so that a drawing can be more easily understood or visualized. Sectional drawings are multi-view technical drawings that contain special view of a part or parts, views that reveal interior features. Used to improve clarity and reveal internal cross-section of parts. Sectional technical illustrations are used to describe internal details of complicated assemblies. For instance, here we have shown the section view of the differential gearbox, which provides a much better understanding. Many assemblies often have parts fitting into other parts or overlapping other parts. For instance, here in the section view of a fuel injector, we can clearly see its various mating and overlapping internal parts. Section views are needed to look inside such assemblies for better understanding. Let's take an example to understand this better. A section view reveals hidden features without the use of hidden lines. For instance, let's consider a simple part with a key slot as shown. There are times when a minimum number of hidden lines are needed to represent features other than the primary one shown by the section. Observe here that the through and through cavity may not be represented properly with just two views, since it could be mistaken with a circular hole. Now let's observe here how taking an imaginary section plane appropriately passing through the key slot of the fixture plate split the part. Observe that the split view reveals important clarity with respect to the keyhole. Then, when the derived section view is added alongside the orthographic top view, provides complete clarity of the machine's keyhole. Now, let's see how to correctly represent a section area. Figure shows a section view for which the cutting plane passes through the center of a counter bored hole. A line represents the change of planes between the drilled and counter bored holes and is an example of a visible feature that is behind the cutting plane. As shown in the correct drawing, the section line areas are bounded by visible lines, never by hidden lines. Traditional section views are based on the use of an imaginary cutting plane that cuts through the object to reveal interior features. This imaginary cutting plane is controlled by the design engineer. Depending on an object's geometry, these section views can be of any of the following types: full section view, half section view, offset section view, broken out section view. Now let's observe with some sample parts how each of these section views reveal additional details. Full section view, where the section plane go completely through the object. Observe how the cutting plane is drawn and how the cross-hatching line mark the surfaces of material cut by the cutting plane. Half section view, where the section plane go halfway through the object. Half section views are used mainly in case of symmetric objects. Offset sections, where the sectional plane bends through the features that are not aligned. Offset sections are used to show interior features that do not lie along a straight line. Broken out section, where the section go through part of the object. A broken out section view is used to reveal crucial interior features in a small localized section of a large object. Section of solids. After going through section of solid topic, you would appreciate how sectional information of solid helps engineer to capture and understand critical features of part or assembly.